For this video, we are going to discuss on how to use the divergence test to determine if the series will converge or will diverge. So for the divergence test, if the limit of the sequence an as n approaches to positive infinity is not equal to 0, then the series will diverge. Now let us have this given sequence an. So an is equal to n. Now let us identify if the series, the summation of n, when n is equal to 1 up to positive infinity, will diverge or converge using the divergence test. Okay, so we will get first the limit of an as n approaches to positive infinity. Now we know that an here is n, okay, based from the given. And then, if we're going to get the limit of n as n approaches to positive infinity, we know that it is equal to positive infinity. Now, since the limit of an is not equal to 0, then by the divergence test, this series is a divergent series. Another example, let's say we have this given sequence formula 3n over 5n plus 4. Now let us identify if the series will diverge or converges using the divergence test. Okay, so let's get again the limit of an, and that is equal to the limit of 3n over 5n plus 4 as n approaches to positive infinity. Now, we can get the limit by multiplying 1 over n to the numerator and denominator. And so we have this result. And then this one, we can cancel it out, and that will give us 3 over 5 plus 0, because this one is equivalent to 0, and that will give us 3 over 5. So the limit of an as n approaches to positive infinity is equal to 3/5. Now again, the limit of an is not equal to 0. Therefore, by the divergence test, the given series is a divergent series. Another example, so given the sequence formula 1 over n, let us identify if the series, okay, the summation of 1n as n will start to 1 up to positive infinity, will diverge or converge using the divergence test. Okay, so again, we will get the limit of an, and that is the limit of 1n as approaches to 0, and we know that this is equal to 0. Now, since the limit of an is equal to 0, then by the divergence test, the series is not a divergent series. Instead, it is either convergent or divergent. Again, the divergence test, okay, the divergence test will only guarantee us that if the limit of an is not equal to 0, then automatically the series is a divergent series. Okay? However, if the limit of an is equal to 0, it doesn't guarantee us that automatically the series is convergent. Okay? Instead, it will only tell us that the series is either convergent or divergent. Okay, it will depend. So we have to take a look at closer or analyze the series. Okay, so for example, this one. So by using the divergence test, we know that the series will either converge or diverge. Okay? So we have to look at the summation of, or we have to look at the series. So we have to look at the summation of 1n. So here is the partial sums, or here is the sequence of the partial sums. So ang 1, that is a1. Ang 3, 2 is when we add a1 plus a2. Okay? Ang 11 over 6 is when we added the 3 sequence terms. Okay? So, tingnan natin yung sum nila. So, kung titingnan ninyo from 1, then 3 to, I think that's around 1.5. Then 11 over 6, I think that's somewhere 1.75 or let's say 1.8. It's just an estimation. And then ang 25 over 12, that's around 2.2. Okay, this is just an estimation. So kung titingnan natin, as the sequence terms nag-i-increase, okay, nag-i-increase ang sequence term dito sa series, tingnan nyo yung sum, yung partial sums, nag-i-increase din. Okay, nag-i-increase ang partial sum from 1, 1.5, 1.8, 2.2, nag-i-increase. So, ang ibig sabihin yan, okay, ang ibig sabihin nito, na yung series natin, okay, if we're going to get the limit of our series, it will be positive infinity. Kasi nga, nag-i-increase yung sum. Okay, nag-i-increase ang sum. And so, if we are going to use the definition that we had sa previous video natin, na kapag ang limit ng series ay positive infinity, then the series will diverge. The series will diverge. Okay? Since the limit is positive infinity, therefore the series will diverge.